Do you get notification also? This session is recorded.
Yes, sir.
There's a
Okay.
audio which plays for that.
What? Yeah, Jordan?
No, I said so. There's some audio which plays for that whenever the meeting recording starts.
Yeah. No, it's just like motive of this class was there was class for the veterinary student. Okay, so
You're taking
I
classes for veterinary students now, sir.
no, there was some other person was taking class. I was just checking how is he taking. I felt ki I can also take.
So for that you can charge higher, no?
Yeah, no, but the thing is ki it's always about the teaching method. But I was saying ki person was just reading the content, and I was like, why? So come to the crystal field theory. Most important topic, very easy topic to understand. It just ki there are so many information about this topic, so we get confused. For this, first you should know about the d orbital. You know, you have total 5d orbital. If all the 5d orbital have same energy, if all the 5 d orbital have same energy, this is known as degenerate. So if somebody asks what is degenerate, degenerate means orbital have exactly same energy with each other. Such orbital are known as degenerate orbital. One thing. Okay. Second, so example, if you have gaseous atom, if you have gaseous atom, so in this case, like individual atom, only metal. So it will be degenerate because there is no influence of other element. Okay, only that particular element. Correct. But we know metal are influenced by ligand. Okay. Metal are considered as ligand. Also in d orbital, when we said there are 5d orbital, there are different name of 5d orbital. Example, I will. These are the d orbital. 1, 2, 3, 4, 5. Okay. These are the d orbital. Each d orbital have some name. Example, first d orbital is dxy, second d orbital dyz, and third d orbital dzx. They look almost similar to each other. It just axis will be different. Okay, but in middle you always write dz square, then dzx, dx square, y square. Okay, so what happen? Example, what how we can represent dxy? We already did in the atomic structure. If you take dxy, आहो कुछ काम तो आया नहीं हो. So dxy means you have x-axis, you have y-axis, and your orbital are present between this dxy. एंग हुआ था ज्यादा. Okay. Second, dyz, only axis will change. Almost things will be same. dzx, it means one axis will be z, another will be x, or it would be ulta. All these three orbitals look similar. Everything is same. It's just the axes are changing. Okay. So these three orbitals look exactly same to each other. Such orbital between the axes are known as T2G. Okay, so if somebody asks what is T2G, T2G contain three orbitals and all three orbital will have exactly same energy. क्या कर दिया? TVS कर दी इसमें ना नहीं कटे हैं क्या लिखा था क्या उसमें TVS एक मिनट just give me 1 minute guys तोड़ दे तोड़ दे TVS नाम तो कोई ऐप नहीं तो कुछ और होगा ना हाँ TVS है तो TVS था एक मिनट फिर कट गया वेट परमानेंट लाना है नहीं वो सड़ी बंद मार Yes, guys. So these three orbital have exactly same energy. Everything looks similar. Only axis is different. Such three orbital are known as T2G. Here you have three orbital X, Y, Y, Z, and Z. Okay. Then there will be two more orbital where you will have on the x-axis and y-axis. This is d x square y square. And last, if you take z-axis and it is present on the along with the ring, so this is dz square on the both sides. These are the five orbitals. Imagine if any ligand is approaching the metal. Any doubt up to here?
No, sir.
Now we'll come to the main part what is given in NCRT. In your CFT crystal field theory, it is an electrostatic model. Okay. What is the meaning of electrostatic model? Means in this case, you will consider positive and negative charge. How? Because you know in coordination compound there are two things. One is metal, second is ligand. Metal is considered almost like positive charge. Ligand have two possibility. It could be negative charge anion or it could be neutral also. Example H2O, NH3. This is neutral. Example NH3 or H2O or something else. Carbon monoxide. Correct? These are the neutral. So that's why the kind of bond you will consider here will be the ionic bond. Because you have ion, metal ion, and ligand. It could be anion or neutral. Understood? Whenever you are taking a ligand, if you are considering anion, you will consider anion as the point charge. One single point. And you will consider neutral molecule as the dipole. Why Sara dipole in case of neutral? Tara, why dipole? Because in case of neutral, there are both positive charge and negative charge. Same in the dipole, you have both positive charge as well as negative charge separated by some distance. Positive and negative amount is same. Net charge is zero in case of dipole also. Understood? Okay. If you take five orbital, one, two, three, four, five. These are the five d orbital. All will have same energy, so we will call them degenerate. Okay. If if any ligand approach them, if any kind of ligand approach them, then there will be electron repulsion. Then there will be electron repulsion, and because of this electron repulsion, energy of the orbital will increase. One, two, three, four, five. Energy will increase because of the ligand are approaching them. Stress level will increase. Okay, ligand approaching them and stress level will increase. So what will happen? All the energy of all the d orbital will increase. You will say ki this degeneracy will be there, but it will lift up. Why? Because initially d orbital were having low energy, but same energy. After ligand approaching them, stress level will increase, energy level will increase, but still all the orbital have same energy. So degeneracy is lifted up. Okay. And ultimately, because of the high energy, these orbital will break into two levels. One into orbital known as EG, and second in three orbital known as T2G, known as T2G. So you have total five orbital. Two are EG and three are T2G. What are these three T2G? DXY, DYZ, DZX. EG to dx square y square and dz square. Okay. Your next question is sir, why when there is a breakdown of all the five orbital, why EG is up and T2G is down? Why ulta is not possible? Make sense? Okay. Why this is happening? Answer is example. We are saying ki we know metal made up of electron. Metal contain electron. Ligand also contain electron. So what will happen when ligand approach metal? Then energy level or stress level of the metal will increase. Because of this, there will be electron repulsion. Electron of what? Electron of metal will repel electron of the ligand. So energy level will increase. And due to this repulsion, what will happen? There will be splitting of d orbital. There will be splitting of d orbital. D orbital will split into two parts, two orbital part and three orbital part. The question is still, sir, tell us why EG is above and T2G is below. And the answer is, it is how ligand approach. Example, In case of easy, example, you take dx square y square. In this situation, you know if ligand is approaching in this way along the axis, repulsion will be more. And if repulsion is more, then energy level will be more.
So it's the ligand which approaches along the axis, or it's the electron which is already existing there?
It is ligand which is approaching the metal. It will be the repulsion between the metal electron and ligand electron. But ligand is approaching metal.
So won't the ligand approach like between the axes? Because
Both. It will happen both because here you have dx square y square. Same thing happen in case of dz square. Along the axis, repulsion will be more. Correct. But if you take xy or yz or zx, what will happen? It is between the axis. Repulsion in all these three will be less. Less repulsion means less energy. Less energy means more stability. Make sense? Less energy means more stability. Here, in these two situations, you have more energy and less stability. This is the key factor to understand the whole mechanism. There is a gap, energy gap between these two, T2G orbital and EG orbital. Can electron jump this gap? This is octahedral crystal splitting energy. How much energy is required so electron can jump from T2G to EG? So understand this. Just give me 2 minutes and try to correlate this. And if you don't understand, let me know. So guys, understood what I said as of now? Ligand approach the metal. As it approach, energy level of metal first increase, as you can see here. After increasing, if it is still approaching, then what will happen? It will split. Splitting out of 5 orbital, 2 will go up. That is present along the axis. Along the axis, electron-electron repulsion will be more. Between the axis, repulsion will be less, so energy will be less in these three T2G orbital. Got it? Okay. So, if you understood this, then you know what is happening. You have 5 orbital. 1, 2, 3, 4, 5. These are the 5 orbital. When ligand approach this, then it will convert into 2 orbital T2G and 3 orbital EG. Sorry, T2G and EG. There is a breakdown of these d orbital due to presence of ligand. Remember, ligand play biggest role how this d orbital will break. Okay. There will be average energy level center between the energy level of T2G and EG. This center is known as barycenter. Barycenter. And you know this energy is very very high, so this level will be comparatively high. Out of 5 orbital energy, 3 orbital energy will be taken by this, and only 2 orbital energy will be taken by this. 2 by 5 total will be 1. Correct. In this situation, if you take total difference between the energy level, this is the for the octahedral. For the octahedral, what is the energy gap between these two? Ask me your doubt till now. Anvita,
No doubt, sir.
Chandana,
No doubt.
Jordan,
No, sir, no doubts.
Sarah,
No doubt.
Varinder.
No doubt, sir.
So what we learned here, we have metal and ligand. In crystal field theory, we consider them ion. Metal as positive ion. Ligand could be negative or neutral ion. When ligand approach the metal for bond formation, for formation, when ligand approach the metal energy will increase in the beginning, and then metal orbital break. Metal orbital break. That breaking of metal orbital is known as crystal field splitting. Field produced by the ligand will cause splitting of field will cause splitting of the d orbital, crystal field splitting. That is, this lambda is the energy level where we are talking about the crystal field splitting. This lambda for octahedral, lambda O. It is for octahedral. Okay, I will write short form crystal field splitting CFS. Now we are saying that this crystal field splitting will depend upon the many factors. Who will decide what is this crystal field splitting level? Did I tell you story last time, Jordan and Sarah?
So your voice is breaking, sir.
Did I tell you story last time?
About
This
No, sir.
did I teach you this topic?
No,
you
sir.
taught the topics, but not the story from last year.
Last year there was not story. Okay.
Only for SN1 and SN2 I remember, so after that you haven't given much of stories.
Let me get the earphone. I think there is a voice issue. I'm getting earphone. Mummy, the earphone is there. Am I audible, guys?
Yes, sir.
Better voice quality, or is it same, or you have better voice quality?
So now it's better.
Okay. So I was talking about a story. According to story, what happened? You have a good, healthy family of 5 people, and everybody is happy in the family. They're enjoying the life of joint family. Okay. Then in this joint family, somebody will come in family, try to approach, and because of this approach, maybe some negative person come. Probably negative person will come in the family, any enemy. First, because of this enemy approach toward the family, their tendency to stay together will decrease and energy will increase, lift up. Then, you know, what will happen when they fight for long time, 6 months, 1 year? Ultimately, they will get separated. They will get separated. After separation, example, they live on two floor, ground floor and first floor. Easy is first floor, and this is ground floor. So if any of their relative will come in future, where they will try to go first, ground floor or first floor? Ground floor or first floor?
Ground floor, sir.
Ground floor. That's why you will see electron will be first filled in the T to G and then in EG. Now, whether relative go to first floor or not, it depend how is the bond between the ground floor and first floor. Like people, are they extreme enemy? They will say, if example, I am a bad person, so I always feel enmity with my family people, like my brother. So what I will tell to my friends or my relative, don't go to him, don't go to his house. Otherwise, I'll not talk to you. It's like that. Understood? So up to three people, this person who live on the ground floor can easily accommodate people. Now, after like three people are staying together in his house, now it will be the fourth person who can easily go to the first floor, his brother house, or they have so much enmity that they will try to congested in the same room. Though they will feel congested, it will be too crowded, but still they try to manage. It depends upon the bond between them. What is the energy difference between them? So, how this breakdown happen? Crystal field splitting means breakdown of the family happen. It depends upon the two factors. Who was the guy, the person who was trying to split the family? Like, was he very strong enemy or just okay? And second, how was the bond between the brother? If charge is high, then breakdown chances are more. If charge is less, they are settled, neutral. So breakdown will be less. Make sense? Understood? Based on this, you will see that there are different type of ligand who have different type of impact. Ligand that have different type of impact. Some ligand are strong, another ligand are weak. Okay, some ligand are strong, another ligand are weak. If it is a strong ligand, ligand can be two types, strong and weak. Whether a ligand is strong or weak, you cannot simply tell by looking at them. you have to see their result. Make sense? So we have to do experiment to define whether a ligand is strong or weak. Experimentally derived series we get. And in this series, we test different type of ligand and see what is their power. Example, carbon monoxide is a strong ligand and the strongest ligand. If this ligand is there, it will cause pairing. Why? Enemy. It's like relative enemy. You can assume like that. This enemy is relative, but still, it tried to do more separation between the two brothers. If this enemy is strong, what will happen? He will stay only in one brother house, and another brother will feel bad. Oh, nobody's coming to my house. Like they feel congested, but still going to the other house. First is the carbonyl. Second, cyanide. Third, ethane 1,2 diamine. Fourth, ammonia. Fifth, EDTA, EDTA, EDTA 4 negative. Then NCS, then H2O, then C2O4 2 negative. Understood? So usually you will feel that these are the strong ligand. You can't remember this sequence in the first instance, and that is absolutely fine. You are not supposed to remember. But you should correlate whatever you studied. Example, in valence bond theory, we have studied carbonyl, this is strong ligand. We studied cyanide is a strong ligand. You will study ene is a strong ligand. In cobalt, hexaamine cobalt, we had this, and you had this also, this strong ligand. And in one of the question, water is also strong ligand in the question, not in theory, I taught. Okay, so these are the strong ligand. After that,
So,
you will, yes, Jordan.
so last year, so when Usha ma'am was teaching us, she told that water should be considered as like the midpoint. So anything that is above water is considered a strong ligand, and anything below water is considered as a weak ligand. So,
Okay, you told me last year also. Let me show you this thing.
uh that is
If
again
this is the
true.
situation, tell me why it is dimagnetic. Why this?
Okay, then it's a
Is-
strong ligand if it's diamagnetic.
Exactly. Tell me why this is dimagnetic. Because
Because it's
if you take this as weak ligand, cobalt have three positive charge, correct? In this situation, three positive charge means 3d6. If it is a weak ligand, what will happen? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. What will happen? You have four unpaired electrons in case of weak ligand. What will happen in case of strong ligand? It will cause pairing of electron. One,
yes,
two, three, four, five, six. Tell me, is it a strong ligand or weak ligand?
strong.
Exactly. Even here it is saying ki cobalt, this is showing inner orbital complex. Make sense? That's why even by mistake I can say something. And any teacher who teach so much content might make mistake. I won't criticize any teacher for making mistake. It is absolutely fine. But NCRT is saying this. We can't deny. Yes or no?
Yes, sir.
Anybody have doubt?
No, sir.
No, sir. No, sir.
No.
But just imagine ki if she told something, she won't be wrong. Correct? That's why,
Yes, sir.
where is this? You will see, if you consider water, water is generally considered the standard, come under intermediate. So, if you take C2O4 2 negative oxalate, it is generally considered weak ligand, but generally not always. But with cobalt, it is strong ligand. Got it? And you will ask, sir, why chelation? Because oxalate is a very good chelating agent. Chelation. Understood? Because it is a very good chelating agent. It will cause electron pairing due to the chelation. Got it? That's why, because of this, the verdict what I can give you is C2O4 is an intermediate ligand, not very strong, not very weak. It will be intermediate ligand. Got it? Intermediate ligand. Jordan, any doubt?
No, sir. No, sir.
So that's why most of time in because it is given in NCRT, you consider mostly these are the strong agent, but what you said is also correct. But in both the question, what we have seen so far, H2O and oxalate were considered strong ligand, though actually in the reality it should be intermediate. Real strong agent are this. These are proper strong ligand. Okay, strong
Yes,
field will
sir.
be there. And after that, you will usually have like all the halogen and halogen are weak. Example, fluorine, then sulfur, then chlorine, SCN negative, bromine, and iodine. If you see here, at least one thing you can compare between the all these atoms. If you consider halogen, strong and weak field is look more like electronegativity. Correct? Like if element is more electronegative, then it will be strong like it. But not universally correct. Otherwise, fluorine would have been the biggest, like strongest ligand so far. Because charge is also one of the factors. What is present? Even neutral molecule are strong like carbonyl, then ene, ammonia. These are the strong ligand without any charge. And this is actually limitation of crystal field theory. According to this, Any negative, because electron repel each other, should have more energy, strong ligand, but actually here neutral molecule are strong ligand. Understood? Next, up to 3 electron, up to D3, doesn't matter whether you have strong ligand or weak ligand. Why? Because up to here there will be no pairing. And we discussed this point already, correct? If you have 3 electrons in the d orbital, doesn't matter. You have this Eg, this will be T2G, and T2G will have lower energy, so electron will be filled like this. We have issue in the fourth electron, whether fourth electron will go to Eg or T2G, whether pairing will happen or not. Right? To explain this, we introduce one concept of pairing energy. And this is where overall you will see, based on this series, pairing energy. Based on this series, we will decide whether an molecule or atom is strong ligand or weak ligand based on this series. Okay. This is known as spectrochemical series. It will be spectrochemical series. So, what is this spectrochemical series? You have multiple chemical in the form of spectrum, a big range, and we assign these chemical based on their power, ligand power. Are they very strong ligand or weak ligand? So spectrochemical series, correct? Spectrochemical series. Using this spectrochemical series, we will explain this pairing energy. Chandana, what is this pairing energy P? It is the energy required for electron pairing in a orbital. Pairing energy, amount of energy required to fill both the electron in the single orbital. So there are two situations. If your crystal field splitting energy is less than pairing energy, Jordan, what does it indicate? This pairing energy is very high.
Yes, sir.
It means pairing is difficult.
So that means it is a strong ligand, no, sir. And the
If pairing is difficult, it means it will be weak ligand. Pairing is not
how,
happening.
sir? Oh, okay. Pairing is not happening, sir. Yes, sir. Yes, sir.
It will happen in case of weak ligand. Example,
Weak.
you have two T2G and EG. You already had 3 electrons in T2G. You are choosing fourth electron, whether it will cause pairing or it will go to EG. The answer is, in this case, it will go to EG. Why? Because pairing energy is too much. You need a lot of energy to make it pairing. Understood? So these are the weak ligand, and here in weak ligand you get the uh, spin pair, spin free or high spin complex. Correct? From valence bond theory. Any doubt? Second possibility, if energy required for the pairing is very, very less compared to this breakdown, compared to this gap, energy gap, what will happen? Anvita, if this pairing energy is very less.
Yes, less. So pairing will be easier to do, and then it will be strong.
Pairing will be easy.
Yeah.
Pairing easy means
Low spin.
fourth electron will come to T2Z, not easy. So here you will have strong ligand. Okay. And you know, strong ligand cause pairing. Strong ligand cause pairing. Pairing. Weak ligand make pairing difficult. Understood, guys? The strong ligand, you know, it is spin paired or low spin. It is same thing what you studied in the valence bond theory. It's just because of the pairing energy. Pairing is decided. Okay, so if your relative is extremely bad, like have some jealousy, lot of enemy factor. So what he or she will cause? They will cause pairing. What will happen because of this pairing? Gap between both the brother is very high. That's why this pairing is happening. Correct? Because this delta note is very high, means gap between the two brother is very high. That's why pairing is happening. If gap between the two brother is less, this delta note is gap between the brother. If this gap is very less, so relative can go to the other brother house also. Won't make much difference, right? Make sense? If you have weak ligand, like enemy factor is not such a big thing, then they will be free. They can enjoy. But if enemy factor is too much, then movement will not be too much because there is already pairing.
So
Low
I'll be
spin.
back in 5 minutes, sir.
Sure. Any doubt, guys? This is the most important factor in the crystal field theory. Pairing energy. If pairing energy is too much, it means pairing will not happen. Pairing do not happen in case of weak ligand. If pairing energy is very less, so it means pairing can happen easily. It means it is a strong ligand. Understood? That's why up to D3, as I mentioned before, you doesn't matter whether it is a strong ligand and weak ligand, but you will see from D4 to D7, you will see more impact of the field, whether you have strong ligand and weak ligand. And you will see from this to this, strong ligand will make compound more stable. Strong ligand will make it more stable. What if compared to the weak ligand? Any doubt, guys?
No, sir.
Now tell me, was it really difficult? Uh, Series will take time. Spectrochemical series will take time to understand. But you understood key? If ligand is weak, it will not cause pairing. Pairing energy is very high. But if pairing is happening, it means energy required is very less. So this is the situation. And octahedral situation is done. Tetrahedral is just opposite to this. Tetrahedral is just opposite to this. So we will not take much time. What happened in the crystal field of the tetrahedral? Tetrahedral means coordination number is 4. If coordination number is 4, it means 4 molecules are present. And because what was happening in octahedral, ligand along axis felt maximum repulsion along axis felt maximum repulsion, and whenever there is maximum repulsion, then more energy. Correct? This happened in case of octahedral. But in tetrahedral, shape is different. It is like in between ligand, 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 ligand. In octahedral, it is more along the axis. See, one ligand, second ligand, third, fourth, fifth, sixth. Understood? So if you see, octahedral was more like along the axis, but here along the axis nothing is present. That's why it is present in between the axis. So in tetrahedral, you will see splitting is ulta. Splitting is inverted. If somebody asks why, your answer should be because this time in tetrahedral, all the axes present in between. So anything present in between axis face more repulsion. And what are the in between axes that face more repulsion? It will be dxy, dyz, and dzx. Okay, dxy, yz, zx. These are present in between. Metal is also present in between, so there will be maximum repulsion. Okay, but now it is not strong as the octahedral because in octahedral you had 6 axes. Here you have only 4. That's why energy will be smaller. How? Let's see. Example, you had the same 1, 2, 3, 4, 5. You have total 5 d orbital. First, when ligand approach it, energy will be high. Then it will break into 2 parts. One is T2G, T2, not G. We don't use G here. And here you will have 2 orbital only, E, not EG. And reason why we don't use G here because no symmetry. Lack symmetry in case of tetrahedron. If it lacks symmetry, G will not be used. G will not be used in this situation. Ask me guys your doubt ki sir why in octahedral EG was up but in tetrahedral E is present below. Because in octahedral metal was present along axis. Along axis orbital will face more repulsion. That's why EG was above in octahedral. In tetrahedral, metal is present in between. X, Y, Y, Z, Z axis also present in between. They face more repulsion and T2 value will be high. Okay. This is like very simple. Energy gap between these two will be known as energy gap crystal field splitting for the tetrahedral T. And here, this energy will be high, 2 by 5 of the total energy. And this will be 3 by 5 of the total energy. Ask me your doubt. Overall energy in the tetrahedral will be less, we already said. How much? Tetrahedral energy will be 4 by 9 of the octahedral energy. It is less, very less. And because of this very less energy gap between these two is very less, electron can easily jump from the one orbital to the another orbital. I will write here. Because this delta T is very small, energy gap is less. Energy gap is less. If energy gap is less, electron can easily jump from E to T2. And if it can easily jump from E to T2, then you will see low spin are very rare. It will be mostly high spin. Low spin, very rare. Okay? Low spin is very rare. Why? Because when electron is easily jump from one orbital to another orbital, it means mostly you will see paramagnetic nature. Mostly you will see high spin. It means high spin is very common. High spin is very common. And your crystal field basic understanding is done. See this properly and ask your doubts. Ask your question, guys. Ask, ask, ask. The main part of this chapter is done. Now we'll do only application part. Just take 5 minutes, observe this, and ask your doubts. Your screen is on. You can ask question.
So no doubt.
No doubt. Okay. Other guys, go through it, like revise full crystal field, and then ask your doubts. Read complete crystal field through the notes. Go through notes. Don't write anything. Just go through notes and tell me your doubt. नूनी मजा आ रहा है ये नाम इसका ये तो नूनी है गलत नाम मेरा लग गया ये तो पता है क्यों बताया भाई नाम ने हैं? पहले लूनी था तो
यार इतना तो प्रेशर है यार प्रेशर है यार मैं भी आ रही शिफ्ट में
के
शिफ्ट में भी आ रही
कितना?
कम से कम 2-3
बहुत बढ़िया।
तेरे इतना चलो ये तेरी 12 फुट दे रे
हैं?
ये तेरी 12 फुट दे वहां
फिर इतना तो था ही नहीं, पहले एक को तो अर्धा लाया था।
तीनों लूंगा
हाँ फिर ठीक है। फिर लगा कि हाँ कुछ दम की बात है। डन गाइज। Are you done with crystal field theory? Is it easy?
Yes.
Are you reading this for first time properly?
Yes, sir.
Okay. Jordan, any doubt? Jordan, Barinder,
No doubt, sir.
Anvita.
No, sir.
Who else is there? Jordan is not there. Okay. So, see, like we spend half an hour probably on this topic or 1 hour, but let's revise same thing in 2 minutes. Crystal field theory, a theory that explains how ligand field will impact the orbital of matter. How field of ligand will impact the metal. And in the presence of the field of ligand, metal orbital will break. 5 orbital break into 3 and 2 number. It is known as T2G 43 and EG 42. In tetrahedral, it is ulta. Like, so what happened? Because metal have electron, ligand have electron. Metal electron are present along axis. So dx square y square and dz square will be repelled maximum. That's why EG will be up and T2G will be down. Ulta in case of tetrahedral. T will be up, T2 will be up, and E will be down. We don't use G in case of tetrahedral because there is no symmetry. Okay. Now, ligand and metal are considered as the electrostatic model where metal is positive, ligand are negative. When negative approach positive, then field will break down into two part T2G and EG. How this uh, like these orbital breakdown and what is the energy between them? It will be decided by the nature of ligand and charge on the metal. Example, there are some strong ligand. Example, carbon monoxide, CO, carbonyl, or it could be cyanide, it could be EN, it could be amine, correct? There could be weak ligand like halogen, mostly halogen or sulfur. So, what is the impact of this strong and weak ligand? Strong ligand cause pairing. It means pairing energy is low. And weak ligand do not cause pairing because pairing energy is very, very high. Okay, up to 3 electron, there is no issue. From 4 to 7, strong ligand will have more impact. Okay, and Anything else? Yeah, that's the mostly thing. If you compare in case of tetrahedral, crystal field will be ulta and energy will be very less, 4 by 9. There is no symmetry in tetrahedral in 4, but square planar and octahedral have symmetry. Okay, and yeah, done. If you are okay with it, color. Color, because of the crystal field theory we have learned. Okay, by the way, one point you can also add. In case of octahedral and square planar compound that has square planar geometry, these have square planar, they have center of symmetry. There is proper symmetry in this case, but no symmetry in case of tetrahedral. Okay, because we said no symmetry in tetrahedral, we need to mention this also. Next is the color of the compound. We said one of the limitation of valence bond theory is they can't tell color, but crystal field theory can tell you color. How? Whenever some color is absorbed, complementary color will be released. So color of compound or complex will be complementary to color absorbed. Complementary to color absorbed. Example. If any compound absorb green color, then color of the compound will be red. This is the color of the compound. What is the reason? Crystal field is deciding the nature. Crystal field is deciding the nature. Example. If you take titanium H2O6 molecule and overall one positive charge, you know in this case electronic configuration will be one positive, let's take three positive. If you take titanium 3 positive, you know titanium electronic configuration is Shakti 3d2 4s2. If you remove 3 electron, it will be 3d1. Now you know titanium 3 have 1 electron in this case, so it will be colored. We don't care which color. More important is if you have some unpaired electron, it will be colored. Okay, NCRT mentioned the violet color, but more important is it is colored. But if there is no unpaired electron in the orbital, it will be colorless. Okay. And if anybody asks what is the reason for color in this compound, answer will be color of the compound due to D to D transition. It means electron will move from one D orbital to another D orbital. And because of that, there will be transition change. Understood? And how is that possible? Because of due to presence of light. That's why in crystal field theory we discuss about the how ligand presence is impacting the nature and energy. Correct? Which energy will be produced? What will be the wavelength of the color? Will be decided by the crystal field theory. And this was the question in 2025. If you know energy, you know energy E is equal to hc by lambda. So if energy is more, then wavelength will be less. Correct? If crystal field energy is more, then your wavelength will be less. And based on this, we will solve question of NEET 2025. So we said there is a color of the compound due to DD transition and due to presence of ligand. It means what happens if no ligand is present, no color. Okay, it means no ligand is present in the system, no color. As simple as so. Ligand are responsible for color. Example: if you take this titanium H2O, 6 molecule, and this is Cl3. So this is a colored compound. Okay, it is a colored compound because you know titanium have one positive colored violet color. Correct. If you heat this, strong heating, what will happen? Water will evaporate. Water will evaporate. In this situation, what will happen? If you remove all the H2O, this titanium chloride, this will be colorless because you don't have any ligand. So removal of ligand, that is H2O, is responsible for the colorless nature. Okay. I'll give you one more example. No ligand means one more example. One example is this. Second example. If you take copper sulfate, this copper sulfate, if you take anhydrous means without water, no water is present here. So it will be colorless or white. White means colorless. Same thing. But if you add water in it, copper sulfate, and you add water in it, it will become blue color. What is the reason from colorless white to blue color? Because these H2O molecule will act as ligand. It means you will understand ligand are extremely important to show what is the color of the compound. Understand? Any doubt, guys?
No, sir.
Any doubt? Huh. Even if you change the number of ligand, color will also change. NCRT have given this diagram. I will show you. This. Okay. See, even this DD transition is given. So what happened? Example, electron was present in the ground state T2G. Electron gets excited, it reaches to the EG. What will happen? It will release some energy, and this energy is responsible for color. This is the excited electron. Again, it will come back to the ground state by releasing energy. Understood, guys? Understood? Second, this part. If you see nickel with 6 H2O is green in color. But when you add one in, when you replace ligand, then color is changing. When you add more in, color is again changing. When you add all in, color is again changing. What does it mean? It means color of the compound depends on the nature of ligand. This is the best example how color is responsible for the different color. Sorry, color is responsible for the different nature. Correct? You can see here. This is green color because only H2. When you add one in, light blue, slightly dark blue, and this is pink. Correct? What is happening? Same change in the ligand is responsible for the change in color. That is the simplest meaning of this. changing ligand is responsible for changing color. Okay, next, color of the gem. Example, if you take ruby, ruby is mainly made up of the aluminum oxide. Ruby is mainly made up of aluminum. But this ruby also contains only very small percentage of chromium, hardly 0.5 to 1%, only this. But because you know that chromium 3 positive is 3d3, you have unpaired electron. This unpaired electron will undergo DD transition. And if there is a DD transition, what will happen? Color. What will happen? Color. Makes sense, guys? It means DD transition in your crystal field theory is responsible for the color. Any doubt? Anybody have doubt in this?
No, sir.
Emerald, if you see same, chromium will occupy at the octahedral site. In the mineral, this mineral again contain aluminium, beryllium, aluminium, silicon, and oxygen. Okay. So what will happen? Color will change, and color is responsible. Like due to the DD transition, what will happen? There will be different color. Correct, and that's why it will transmit different color and it will look green. You can see in the second diagram, it look green. In the first diagram, orange pink color. Reason, same, DD transition. Understood? So these are the two stone kind of structure you will see. Okay, there is color in this stone. And what is the reason for the color? DD transition of the element. And what is the element responsible for this color? Chromium 3 positive in both the situation. Whether you take ruby or emerald. Reason is same. But main compound is different. In ruby, it is aluminum oxide. In case of beryl, it contains beryllium, aluminum, silicon, oxygen, everything together. And this is responsible for color. Last, we know because of the crystal field, we can understand how compound form. We can understand what is the structure. We can understand color. We can understand magnetic property, how unpaired electrons properly explained. But the problem is in this case, we are considering ligand are the point charge. We said in the beginning, okay, we consider ligand as point charge, correct? So it means your anion ligand should exert the maximum splitting effect logically. Okay, logically, negative ion or negative ligand should have maximum splitting effect. But in reality, when you go through the table, you get to know you you have carbonyl in on the higher side, ammonia out of top four, three are neutral ligand, correct? So it means this is not foolproof method where everything is perfect. Logically, it doesn't make sense. We said negative charge should exert maximum force, maximum splitting, but here we can see carbonyl, in or ammonia is exerting the maximum. Actually, they are present in the middle, negative ion, usually. Usually, correct? Second, here we talk only about the ionic bond. It does not consider covalent current. It considers only ionic current. Correct? And in the higher class, you have LFT, ligand field theory in the graduation. Molecular orbital theory we have in the 11th class. MOT, molecular orbital theory. Okay, how small molecule can show that. But you will feel ki MOT is mainly for the small molecule, O2, N2, Cn negative, like this. For bigger structure, it is not eligible. Tell me, guys, any doubt? Any doubt? After this, you have just application part. Everything is done. Tell me, was it extremely difficult to understand crystal field theory?
No, sir. No, sir.
Okay. So last topic of this, after that only application will mostly do. Homolaptic carbonyl means a compound that have mostly. Oh, Jordan is not there. Why? Sarah, am I audible?
Yes.
Sarah. So crystal field is done. Carbonyl, very small topic, very few questions. Homolaptic carbonyl means a compound that have only carbonyl, nothing else. Like this. X amount. We don't know what is the amount. And you know carbonyl is neutral, so metal will be also neutral. Correct? So this is homolaptic carbonyl, only one type of ligand. Okay. And these are very simple and well-defined structure. Charge will be zero. Example, it can happen in case of nickel, in case of iron, in case of chromium. Okay. Example. If you take manganese, in manganese you have 10 carbonyl group. And this 10 carbonyl group have two square pyramidal structure. I'll show you in next page. Square pyramidal structure are given. And there is manganese bond, no bridge. Okay. Example, you can see here. It look like square pyramidal structure. One complete square and two bipyramidal. One pyramid this and second carbonyl is this. Okay. So it is look like square bipyramidal and there is direct manganese bond. Okay. There is manganese direct bond carbonyl group. And same thing is written here. There is two square pyramidal structure joined by this bond. And in this case, yeah, that's all. Second structure is cobalt. In cobalt, there are total 8 carbonyl. But interesting part in this 8 carbonyl, you have two bridge atom and direct carbonyl bond as well. Direct carbonyl as well as there is a bridge bond. Bridge bond as well as direct carbonyl. And need ask this question. I'll show you in the recent PYQ. Look at this. Octa carbonyl dicobalt have cobalt bond, but at the same time here are two CO group in the form of bridge. In the form of bridge. See, in case of 4 carbonyl tetrahedral, 5 trigonal bipyramidal, 6 octahedral, 10 in case of manganese square pyramidal, and in cobalt you have bridge. You have bridge carbon, two bridge carbon. And last important topic is extremely important. Um, Chandana, what should happen whenever any metal form bond with any ligand? Only ligand donate electron, right? Like this. in any coordination compound, only ligand donate electron to the metal, right? But in this synergic bond, even even metal can donate electron to the carbonyl. That is the special thing. Mostly, only ligand donate electron to the metal in coordination bond. But in case of carbonyl, even metal can donate electron to the carbon, as you can see here. Pi and pi and T are forming bond with each other. So pi bond is formed by the here pi bond is formed by the between the metal and carbonyl, and here metal is donating electron. Understood? So in this case, you have both sigma as well as pi character. Both sigma as well as pi character. Sigma bond is formed when carbonyl carbon is donating electron into the metal. This I will rub this again. This is mixing. As you can see here, this sigma bond is formed when carbon is donating its electron to the metal, right? But pi bond is formed when your metal is donating electron into the anti-bonding orbital of the carbon monoxide. That is unique thing. Usually there is only one donating atom, but here both are donating each other. Okay. This effect, when both donate each other, known as synergistic effect. Both are benefiting each other. And what is the benefit? Bond will become strong. Okay, that's all. In case of carbonyl, unique thing is along with the ligand donate electron to the metal, metal also donate electron to the carbonyl and form pi bond. So in this situation, you have both sigma and pi bond in carbonyl, and that's why it is given in the NCERT because it is unique. Done. Because it is unique. Done. Chapter is done. It's just application part.
So
Guys, how is it going? Yes, Anuj.
it's going good, sir. But sir, till when will you take the class?
But maximum like up to 4:30 because I'll finish in 5 minutes, 5-10 minutes, and then 4-5 question and chapter will be done.
Okay.
परिंदर कैसा जा रहा है?
Sir, अच्छा.
Chandana, how is it going?
Sir, can you explain synergic bonding once?
Yeah, sure. So synergic effect or synergic bonding is very unique thing because what happen normally you have one metal, normally what you have a ligand, and normally ligand donates its electron to the metal. That is what happens in coordination in all the ligand and metal. But carbon monoxide is unique. Carbon monoxide is unique. Why? In this case, you have both contain both sigma bond as well as pi bond. Normally, this bond is only sigma bond. But in case of carbonyl, even pi bond exists. How is that possible? Because when you consider metal and carbonyl, so carbon donate electron to the metal and form sigma bond as usual. Okay, as usual. But other than that, there will be some special orbital present in the carbon. There will be special orbital present in the carbon. And in this special orbital, metal will donate electron to the carbon. metal will donate electron to the carbon. So bond formed in this situation will be known as pi bond. This is known as synergy effect. It's like A and B. B is donating electron to A. A is donating electron to B. Both are supporting each other, like mutual interaction, symbiotic relationship. So this is known as synergistic effect or synergic effect. Synergic. Understood?
Yes, sir, understood.
Last part is important, but nothing to explain in this situation. Nothing. Literally nothing. Example, lot of importance. First, they are used in the quantitative analysis and qualitative analysis. You measure quantity of any compound, or you measure whether a compound is present or absent. Okay. It is used in the color reaction, whether color is given by the compound or not. Especially color reaction, the chelating agent. Example, ene can also form the chelating agent. Correct. So you can estimate many things. Example, adita have chelating effect. Dimethyl dioxide have chelating effect. Alpha nitroso denathyl have chelating effect. Cuprone have chelating effect. I want to show you dimethyl glyoxime. Dimethyl glyoxime. Dimethyl glyoxime. This because you have two nitrogen, two methyl group. Glyoxy, like OH is usually attached to carbon, but here you have nitrogen instead of the carbon. So this is dimethyl glyoxide. I will show you why I am asking this, but write this formula. Two carbon, CH3, CH3. You have nitrogen, you have nitrogen. Then how many bond are there? Bond completed? Yes. One OH here, one OH here. Okay. So what is happening here? You have electron in this case. You have electron in this case also. This will donate to some metal and form the chelating agent. Why it is special? Because this was asked in 2025 JEE exam. Exactly same. Exactly same thing was asked in your last year JEE exam. Dimethyl glycine. Two methyl group. It looks like oxime. Glyoxine. Okay. Second, in Bangalore or Karnataka, this is very common. Hardness of water. Anusha, did you feel this hardness of water?
Yes, sir. My hair are not like the same volume. Like
Okay. Sarah, Chandana, Chandana, did you feel the heavy water, hardness of water?
Yes, sir.
So hardness of water we can estimate by using adita because this hard water contains calcium salt and magnesium salt. And this calcium and magnesium can easily form uh, chelating agent with the adita. Correct? So it will help to select the specific ion because their stability is different with the calcium and magnesium. Batre. Next, to obtain many metal like gold, we can use the same coordination compound. How? First, this gold will combine with the cyanide in presence of water and oxygen. It forms cyanide, this in aqueous solution. And again, you by adding the zinc, it will convert into the zinc cyanide like this, like zinc cyanide, and gold will become pure. This will help to get you pure gold. Same process is applied to the different compound also. Example, if you take impure nickel, first you convert into the nickel carbonyl, and again you can form pure nickel. Same like gold. Gold and nickel process is exactly same. First you convert into some iron, and then again do this reduction, and you form pure metal. You already did this. Chlorophyll contain magnesium. Hemoglobin have iron, Fe2 positive. Vitamin B12 have cyanocobalamin. Anti-pernicious anemia factor. What does it mean? Deficiency of vitamin B12 cause pernicious anemia. Deficiency of vitamin B12 cause pernicious anemia. Deficiency of vitamin B12 cause pernicious anemia. So, if you provide vitamin B12, pernicious anemia will reduce. So, anti-pernicious anemia. Okay, same way. If you see, there are coordinating metal present in the carboxypeptide contain the coordination compound. Breathing carbonic anhydride react with CO2. This I explained somewhere, I guess, in one of the chapters. Three, rhodium catalyst. This is also known as Wilkinson catalyst. Use of this catalyst to convert alkene into alkane. Alkene into alkane. Hydrogenation of alkene and convert into alkene. It contains what? Coordination compound of rhodium. Coordination compound of rhodium. Then electroplating. Electroplating with the gold and silver can easily happen by using Ag this version or gold this version. So, plated jewelry. Do do you guys know plated jewelry? Recently, I came to know that there is the existence of plated jewelry. Any of you have idea what is this?
No, sir.
No?
Yes, sir.
Okay. So plated jewelry means only gold plating is present. Outer covering is gold. Inside everything is like other metal, iron or copper. Mostly copper. It's very, very, very cheap. And nobody can tell is this gold or not because outer covering is gold, but inner covering is not gold plated. Next, black and white photography. You must have studied this in 10th class, very first chapter. So there will be a special covering when you use with the hypo solution, and AgBr will be there, and Ag can form this complex. So you are making coordination complex or complex compound using AgBr in black and white photography. And last, chelating therapy. This chelating therapy is used to, what should I say? It is reduced to remove the toxin. Okay, remove the toxin. Example, if we consume any toxic substance, example, if we consume a lot of copper or iron, we want to remove this. So for the removal of the copper, we will use D-penicillamine, D-penicillamine, and for iron, as the name suggests, des-ferrioxime B. So what is happening? We are reducing toxicity level by using D-penicillamine and des-ferrioxime B. Same way, if any example in many animal also lead poisoning is common. So we can use EDTA to treat the lead poisoning. And we use cisplatin to treat cancer. This treat cancer. I have seen one JEE question related to this cisplatin. Cisplatin is given in the very starting of your chemistry part, like very first chapter introduction of the chemistry. Cisplatin is given over there. Cisplatin is used there. So if anybody asks what is cisplatin, so platinum have two fluorine and two amine. Cisplatin. Cisplatin. Yes, guys. Chapter 8 done. Anything we'll left? No, we didn't left us. Each and everything is done in 2 days. And questions are repeated in this case and specifically on the one topic. Okay, I will show you in the NEAT question. NEAT coordination compound. Do first question. Correct order of wavelength. Wherever you have strong ligand, more energy. Weak ligand, less energy. Charge also matters in this case. How much charge is given in this case? Got it? So wavelength inversely depend upon the ligand. Why? I told you. I will write here in the end. Wavelength inversely depend upon the energy because energy inversely depend upon the wavelength. You know E is equal to hc by lambda. So E inversely depend upon the wavelength. Wavelength inversely depend upon the energy. And because of that, you know, wavelength is also inversely depend upon the ligand strength. So if you have strong ligand, more energy and less wavelength. Okay, strong ligand, more energy, less wavelength. I will write this. Strong ligand, more energy. Strong ligand, more energy. More energy means your delta naught will be high and wavelength will be less. Very, very, very important. Now compare this. Out of these four, which one is the strongest ligand? Cn is the strongest ligand. So can we say B will be maximum? B will be the strongest ligand. So if it is strongest ligand, you will have maximum energy and minimum wavelength. Where you have minimum wavelength? CMD. So you can eliminate A and B. So you know this cyanide is the strongest ligand. If it is strong ligand, delta node will be high and wavelength will be minimum. So B will be minimum. If you know D will be minimum, you can easily eliminate option A and B. Correct? Then ammonia is second strongest ligand. Correct? Then the second minimum value will be A after B. You can eliminate this. But tell me guys, was it really difficult if you know the concept? Wavelength is related with energy. More energy, strong ligand, more energy, less wavelength. This is simple logical question from the dual nature of matter also. E is equal to h nu. E is equal to hc by lambda. So more energy, less wavelength. And you know strong ligand, then energy will be more and wavelength will be less. As simple as that. Make sense? Right? If this is done, you can solve it. Which one is paramagnetic?
Sir, how to differentiate between C and D in first question?
Hmm. How to differentiate between C and D? Charge. If you have more charge, then it means energy will be more, correct? Wavelength will be less. So if you take sequence, minimum will be D, then A, then will be D, and maximum will be C. Correct? Because we said that this crystal field depend upon the two things. I wrote exactly the same thing. One is the ligand strength, and second thing it depend upon the charge on matter. Do you remember? Same
Yes.
NCERT line. Crystal field splitting, it means energy. Crystal field splitting means energy. This energy directly depend upon the ligand field and charge on the matter. So it was pure NCERT question. Correct? Any doubt?
No, sir.
So here in D, you have more charge, more energy. Charge more, energy more, wavelength will be less. It's just pure based on the ligand and charge. We are not bothered about the element. Here, nickel 2 positive, nickel 2 positive means 3D8. Chlorine is weak ligand, and weak ligand means this is paramagnetic. Here, nickel in case of cobalt will be 3D10, not paramagnetic. Here, nickel 2 positive, 3D8, it will not be paramagnetic pairing. So, if you consider all these factors, can we see the option based on this? A is paramagnetic, so you can eliminate D. B is not, B and C is not, you can eliminate this also. Correct? Now you have to choose out of last two, which one will be there. Here, nickel will be again 2 positive, and if it is 2 positive, it will be 3D8, and if it is 3D8, it will be paramagnetic because weak ligand water. Water will be considered weak ligand in case of nickel because no chelating nature present here. And last, this triphosphite. So in this case, nickel will be neutral. Neutral means AD8 or S2. Correct? So all electron will be paired in this case, so it will be diamond. Any doubt?
No, sir.
No, sir.
So 2025 question. We already did this. Yeah, minimum conductance, minimum ion, minimum number of ion, maximum conductance, maximum number of ion. Here, if you see, you have 4 ion. Here 2, here 1, and 1. So answer will be C and D both. And if you remember, in NEET exam, both answers were considered. Right? Any doubt? Ethylene diamine tetraacetate addita hexadentate ligand. Addita hexadentate ligand. Not ambidendant ligand. CN is ambidendant. This is ambidendant. This is ambidendant. This is not. Correct NCRT. Wherever you have 2 binding sites, ambidendant. See this question. In these 2 structure, metal-metal linkage is present in both. Terminal CO is present. What is the option given? Bridge carbonyl is present only in this. Correct. So choose the correct option. The structure both have metal linkage. Correct. Bridge is present only in the second part. And metal with a zero oxidation state, both A and D is absolutely applied in both. Correct. Terminal CO. Terminal CO means like this. Manganese here, manganese here. Here CO like this. Same in cobalt. Both will have terminal CO. Correct. But this is wrong. Why? It is present only in cobalt. Look at this. Only in cobalt. We saw this diagram. In cobalt, you have bridge carbonyl, but in manganese, you don't have bridge direct terminal. All are terminal. Whatever you have carbonyl, all are. Any doubt, guys? Any doubt?
No, sir.
Isomerism. First, Chandana, A. Linkage. How do I know? And no 2 is ambidendant like. Anvita, B.
Ionization. Isomerism.
Ionization. Bromine can be exchanged with sulfate. Sarah, C.
Coordination.
Coordination. Varinder, D. Because water. It will change the water. Varinder, next question. This and this complex are octahedral but differ in magnetic property. Yes, one is strong. Here you have strong ligand. Here you have weak ligand. Correct. First is dimagnetic, second is paramagnetic. Correct. So both are correct, Varinder. Yes. Both
सर
are
वो
correct.
नहीं है मीटिंग में काफी देर से.
Okay. Only 3 of you are there. Sarah, this is homoleptic. This is heteroleptic. Is this correct? Yes.
Sir.
Second, this contain because only one type of ligand, but this contain more than 2 type of ligand. Is this correct?
Yes, sir.
Yes, both are correct. Anvita, 10th question. Homolactic complex.
1 second. So D.
Yes, because only oxalate have nothing else. 3 oxalate. Chandana, which complex compound is most stable? Chelate. Chelating is most stable. Ene can show chelating. Identate or more can show chelating. Tara, which of the trihalide cannot be hydrolyzed? This is not actually from this chapter, from other chapter. First member cannot show, so it's okay, you leave this. Which of the following form the double salt Sara and complex ion? This is double salt, potash alum,
Yes, sir.
correct? So tell me, guys, is coordination question really difficult? Is
No.
coordination chapter really difficult? So now you can solve question. It's okay if you don't do many, but
So
you
your
should
voice
finish
is
this PDF.
breaking. So your voice is breaking. What did you say?
I said ki you have to finish this PDF by today. Okay, if you prepare less, it's okay. But if you don't finish this chapter, it's not okay. Our current chapter is more important than tests. Understood? So I will send this PDF.
Yes, sir.
First, you have to finish this PDF before test. You have to send me PDF. Is that okay for everyone?